Hello and welcome to another episode of #DisruptionDialogues, a Markets and Markets podcast series for growth-minded strategy, market intelligence, and competitive intelligence professionals. Today our host Pranjal Sharma is in discussion with Zubin Sarkar, Head of Strategy, Business Development and Marketing at Siemens Commercial Vehicles.
Hello and welcome to another episode of Disruption Dialogue. I'm Pranjal Sharma. I'm an author based in New Delhi, India, and I'm going to be in discussion with Zubin Sarkar, who is the Head of Strategy and Business Development for Commercial Vehicles at Siemens. Thanks, Zubin. Thanks for joining us today. We'll be talking about commercial vehicle electrification roadmap and also look at what are the challenges and the changes that we can foresee and what the future looks like.
Thank you for having me and look forward to the discussion.
Great. Now to begin with, I know there's a lot of work you've done personally and through Siemens as well, but just to get the context, we have been discussing personal vehicles all the time as far as the electrification goes, but there isn't a lot of discussion on commercial vehicles. So can you give us an overall sense of where we are on electric vehicles for commercial usage?
Exactly, Pranjal, and as you rightly pointed out, a lot of discussion has happened for passenger cars, not so much for commercial vehicles. And to give you a flavor, this is what we call is the EV decade. So this is the electric vehicle decade as part of the overall sustainability or ESG era, as you could call it. And why I say this is 2 years back, when we were in the peak of COVID lockdown and we were planning for uncertain times ahead, there were a lot of discussions about all these emerging technologies like electrification of vehicles, autonomy, all this could be further postponed because governments would not have money. But then all these views have been upended and there has been an unprecedented scale of intervention from governments in terms of spend, in terms of regulations. So we see billions of dollars now getting poured into electric vehicle infrastructure. We see very tight city level regulations in terms of which vehicles are allowed within certain zones, which also means operators and users, they are also consciously preferring to tie themselves to lower emission or zero emission vehicles. We also see significant private sector partner collaboration plus participation in terms of developing communities with very stringent targets. Like we have the EP 100 for productivity, we have the EV 100 for electric vehicles, we have the RD 100 for renewable energy. And all of this, plus very recently we saw the scale of commitments from various countries in COP26. The developed world, the US, Europe, UK committed to 2050 net zero. Even in the major BRICS economies, we have Brazil and South Africa also committing to 2050 net zero, Russia, China committing to 2060, India committing to 2070. And gradually, the theme of conversation has moved beyond zero emission to net zero. So zero emission is almost like a given, and everyone is now focusing on net zero. And this has translated into real figures on the ground. And for cars, as you just mentioned, at least in Europe, we see 10% adoption for electric cars in 2019. Throughout the pandemic, in 2020, it became 20%. In 21, it became 40% of new car sales being electric. So I'm saying battery or hybrids. And same in China. In 21, we have seen 2.5 times electric car sales in 21 versus 2020. In US, also sales are doubling for electric cars in 21 versus 2020. So it's the momentum has significantly changed for the better for electric vehicles. And you could question, since there are a lot of overlaps in terms of technologies and supply chain between commercial vehicles and passenger cars, this should also be happening for commercial vehicles. And to a good extent, it has happened for buses. And for buses in Europe, we see significant uptick for electric adoption. It was 8%, say, for Europe in 2019, moved up to 14% in 2020. It's now 20% in 2021. So it's gradual, not as aggressive as cars. But the elephant in the room for commercial vehicles is trucks. And there it has not happened yet. So it's largely at a nascent stage, and it's very interesting to see how electrification of trucks would develop. Our internal estimates, given what we see in the market, having spoken to a lot of our customers and their production plans, we think around 2030, 2024 would be a big year for trucks, for electric trucks. So a lot of new vehicles would be launched, new models would be launched. And also we see close to 15, 16, 17% adoption for new truck sales by 2030. So which means we have around 3 million of heavy duty trucks. And when I talk about commercial vehicles, I mean vehicles more than 7.5 ton gross vehicle weight. So we have around 3 million such vehicles annually sold. And we see around 500,000 of that, which is roughly around say 15 or 16% to be electric by 2030. And with significant upsides. I mean, there are a lot of topics which are to be addressed yet for commercial vehicles. And if those topics are addressed, like we have seen for cars, all forecasts are going up. Same thing is expected for commercial vehicles as well.
So you would make a clear distinction between commercial vehicles which involve passengers and commercial vehicles for goods, because obviously the usage, the weight and the device and the profile would be very different.
Exactly. I mean, commercial vehicles for passengers is largely buses, and trucks are primarily used for goods. And there could be some off-road applications as well for trucks, largely for goods. But that's how we classify it. But we don't see any change in trends of electrification, given it is for passengers or for goods. But what we know is definitely vehicles which are meant for goods, they have a very different nature. For example, electric buses are a lot more luxury and performance and driving and passenger experience oriented, whereas trucks for goods, they're a lot more of business case and TCO oriented. And hence the kind of technologies and the kind of mechanisms at play in terms of say financing and then warranties, they are very different.
Within this conversation, there are two elements that we should look at. One is about the technology and second is perhaps about the design. And both will have to work together to be able to deliver on this potential. Now, what kind of changes are you seeing today which will have an impact on the kind of technologies and the design which are more focused on users for electric commercial vehicles?
So for commercial vehicles, especially for trucks, there is a lot in terms of technologies which is still open and a lot of variables at play. And we, at least like till last year, there was several limitations in terms of battery and the battery requirements to meet the range, and there are of course cost limitations and space limitations and everything. So the technology was still not clear. So either you need a big battery to meet the range, and that battery, the weight becomes an issue, or the cost becomes an issue, or the space becomes an issue. And then now we have fuel cells. A lot of fuel cells company proactively investing and a lot of investments also flowing into fuel cells. And what we see is clearly for heavier trucks, say more than 30-ton trucks, we clearly see preferring fuel cells simply because fuel cells, they are expected to be much lighter in terms of, for example, for a 20-ton, or if we take a 30-ton truck, we may need very close to say 7.5, 8 ton of battery size to meet the requirement performance. If we have a fuel cell, that can be easily done for 2.5 tons. So we are easily saving 6 ton of weight, and also the costs are much less. Of course, given all the commodity inflation that has happened recently, some of these costs have to be revisited, but also the costs are less and the space is less. So we see fuel cells really picking up for heavy trucks, especially more than 30 ton. Between 20 to 30 ton, it's really a choice of OEMs and you know what sort of supply chains they have. And less than 20 ton, we still see batteries, lithium-based batteries. And over there also a lot of different technologies at play with, you know, passenger cars largely has been an NMC-driven tech for batteries. For trucks, because of durability and cost, maybe we are also looking at LFP batteries. And not to mention now there are new innovations coming up. For example, Cummins has come up with, say, a hydrogen-based engine. And we have to see how the economics and how this could really disrupt, especially heavy vehicles.
As far as technology goes, Zubin, there is also the autonomous part, which when combined with connected vehicles creates a completely new ecosystem. And then, of course, there is the issue of retrofitting. And you have alluded to that already. Are these going to be the most important dimensions of the change?
Exactly. So what we see is, since for commercial vehicles, since the life is much higher versus passenger cars, which means the replacement ratio of fleets is much lower. So if we say have 30-40 million of commercial vehicles globally, we just have 3 million. Every year 3 million is getting replaced. And since the electric part of this 3 million is also quite small, then what it translates to is this overall fleet that we have, so 30-40 million, only a small fraction is becoming electric every year. So large part of this fleet would still remain conventional. And since heavy vehicles, they constitute a significant percentage of CO2 emissions, heavy vehicles, including off-road and everything, very easily it could be 10 to 12% of your total global emissions. Of course, there are variations across countries, but around 10 to 12%, which is quite significant. We do see electrification happening in very different ways, and that's where retrofit comes into picture. So retrofit could be very cost effective. Retrofit could come up with new technologies, not just electric. It could also be partial or fully autonomous, and you could have other connected vehicle technologies put into the vehicle, because the moment you deploy a vehicle to be retrofitted, it's better to modernize it for all technologies than just doing it for one. And because then you have return on the downtime and the spend that you have. And we see this entire concept significantly coming up. And by 2030, if around 10 to 12% of fleets, if they are electric through conventional, new vehicle sales, another 15 to 20% could be easily targeted through retrofit. So that's a big number we are talking about, and there's a big opportunity in this market.
Let's talk about the business case. There is a case for retrofitting existing commercial vehicles into an electric vehicle. At the same time, there could be other changes which could be happening in the developed country or in emerging markets. So I think some of these issues will also be to decide the kind of investments that are going into the entire ecosystem.
Exactly. I mean, the business case clearly exists. So we are already seeing a lot of opportunities in the market with a lot of retrofitters or even conventional systems integrators coming to us with big opportunities. And a lot of these vehicles, say if we take off-road vehicles, if we take mining trucks, 40-ton, 50-ton trucks, these trucks typically have lives of 15, 20, even more. And if we are retrofitting such a vehicle, say within 5 years or 10 years of its life, and some of the components which are typically a bottleneck to this life, primarily is the powertrain, so that is getting replaced, and also say some other mechanical or say tires and stuff, which could also be replaced. So what we see is the vehicle life is also significantly extended. So it is almost as good as a fresh vehicle, and given all the productivity gains, because it's an electric powertrain, all the CO2 emissions and fuel savings and maintenance savings, this is very clearly, this works out. Now, you could ask, clearly for bigger vehicles, with this clearly works out. If you could ask, would this work for say school buses or something, which is also a big market seen in many countries, we are seeing opportunities. We are definitely seeing opportunities, and maybe part of the solution to this business case is also having very creative financing. And that is where also Siemens, we come into picture. So we also offer financing where a lot of these costs are back-ended, in the sense a lot of these payments would not be done in the initial stages. They would be done at a later stage based on either the number of kilometers this vehicle runs or certain utilization rates for these vehicles. And the idea is, as over a period of time, because of inflation and other cost structures going up, this cost will be essentially coming down. So there are a lot of other methods to really make the business case in favor of retrofitting.
Zubin, let's talk about the futuristic technologies now. What can we expect? You're a domain expert in this field. What should the users, current and potential users, expect from commercial electric vehicles?
I mean, we at Siemens, we offer a lot of technologies across charging infrastructure, drivetrains, and there are beyond Siemens JVs for batteries as well. But I can comment on drivetrains because that's what our business unit focuses on. And what we see is that for the motors, we typically have seen permanent magnet-based motors as largely the preferred model for cars, as well as for city buses and for trucks. Given the durability of, induction motors, given the lower cost structure of induction motors, there is a possibility that could also gain ground. I mean, as of now, clearly permanent magnet motors are the most preferred one, but we are already facing a lot of inflationary cost pressures. And especially for highway trucks, where, given the drive cycle on highways, the energy efficiency gap, which is typically between a permanent magnet motor and an induction motor, that narrows down. And given all the other benefits of an induction motor, we could see induction motors significantly picking up, especially in regions like US and Europe, where a lot of this rare earth is not available. So rare earth is available in abundance in China, and they could prefer a lot more of permanent magnet motors. But in other countries where the supply chains are not there, and a lot of supply chain sovereignty is also a big topic these days, there could be a lot of preference for induction motors. The other thing that we see for heavier vehicles is also the inverter technologies. So we could move to a higher voltage. And since these vehicles, they require much higher power. And for higher power, if we try to minimize the current or reduce the current, we need higher voltage. And lower current can essentially reduce losses, which means these higher voltage systems are more efficient. And given commercial vehicles, they like efficiency, and it's a very TCO-driven industry, we would see movement towards silicon carbide-based inverters. And that is also something that we are also working on. What we could also see is integration of this entire drivetrain. So the drivetrain is something that we sell is the motor and the inverter. Then you would also have gearboxes, especially for trucks. You would have the axle system. There could be differentials and all the other mechanical interfaces up to the wheel. And what we could see is that this entire system, not, today we sell motors and inverters as separate systems, but we could see a lot of this becoming a single composite as a box which is handed over by a supplier to an OEM, or the OEM makes by themselves. And this box is like a plug and play for commercial vehicles. Then it significantly reduces in-house efforts to integrate all of these systems. That's the first benefit. Second benefit is, by design, if it is integrated, there are a lot of design synergies and a lot of mechanical components which are removed, which increases overall system efficiency, which reduces weight of the system. And the space is also much less, which means trucks, again, because they are business case driven, they would like to see more of the payload, and which means if the design load is much less, then that's a big benefit. And also, as we discussed, since there's always a question of a lot of space taken up by batteries, if we can save space on the motors and inverters or the drivetrain itself, that's a benefit. So we see electric axles also picking up in future, not immediately in the developed world, possibly 2025 onwards, at smaller adoption rates. And maybe by 2030 or 35, we see significant adoption for electric axles. What we also see for trucks, the other one is these electric highways that Siemens is offering, which means that if the trucks are on predictable routes, then they would have overhead cables, and there would be a pantograph which can connect or disconnect based on the presence of these cables. And these trucks are then directly drawing electricity and operating on this electricity, which again reduces the battery requirements, especially if a significant percentage of the travel route of these trucks are on highways.
So this is an exciting idea, Zubin. You're talking about charging throughout on a highway. Are there any pilot projects on this which are worth considering and examining?
There are pilot projects. This is another business unit in Siemens. I would not have full details, but there is a pilot project in Germany and funded by the German government. And this is being taken very seriously, because the question is, would it make sense to invest in a lot more of charging stations, or to have these overhead cables? And I think it makes sense, because then you would also significantly reduce the overall cost per unit truck. And I hear about a lot of JVs and between private sector and also funding by the government.
The charging ecosystem is actually quite dynamic right now from what we can see, Zubin, because there are battery swapping options. There is also charging on highway that you mentioned. There could be so many other technologies in that which are also developing. There are multiple options. Will these all coexist, or do you think that with time we will settle down into one form of charging?
That's the thing. And the conclusion is there would be a coexistence of technologies, at least for the next 10 years. I mean, first thing that we understand or conclude is commercial vehicle electrification would be happening. So none of these variables would postpone electrification of commercial vehicles. And especially when I mean commercial vehicles, I mean trucks. So electrification is happening, and it's gonna happen in the next few years, definitely by 2030 across all vehicle classes, be it on-road or off-road. So that's the first trend. The second trend that we understand is there would be a mix of technologies. We already see in terms of motors, we already see some OEMs preferring induction motors, some preferring permanent magnet. Then we also see some OEMs also starting with electric axles, some going with the central motor concept. We already see some deployment of high voltage inverters as well. And then there would be a coexistence. The question is what percentage and to who, how much of the share, to which technology is the big question. And this is of course evolving, and only time would tell. We have our internal estimates, but at the same time, we can only know for sure beyond 2035 or 2040 when you would see significant scaling up for electrification of trucks. That is one. And the various OEMs between themselves, they have to agree to which technologies make sense in terms of convergence. So till that agreement is there, or standardization of specifications is there, we see a healthy participation of all technologies in this field.
So what you're saying is that the transition period will decide which way the market goes. The question then is now, which I would like to pose to you, is your own vision. Where do you think it is heading? What is your contribution and role? Can you help us understand a little bit? How would you describe your role within Siemens, and also what would be your ambition in seeing the ideal ecosystem?
What we are doing is Siemens, first of all, has been a pioneer in commercial vehicle electrification. We have been selling many firsts in this field. So we are possibly the first hybrid electric bus, the first battery electric bus, the first fuel cell truck on a commercial scale. A lot of these projects we have been doing over the last 25 years. And what we plan to do now, given this huge focus on ESG and sustainability and net zero, is we are investing for the best possible technologies. So our products are extremely efficient. They achieve efficiency up to 97-98%. Our products, they have long life and maintenance-free life, and for more than 12 years. And we are using very high quality materials to offer this TCO benefit to many of our customers. We are also designing these products keeping in mind net zero. So not just zero emission, but net zero. A lot of these products that we design, they have more than 40% of the metal content can be recycled or is from recycled sources. We are using very minimal quantity rare earth in our motors to maximize the performance, the bare minimum quantity which is required. And of course, many other design considerations like dismantling, how much of this product can be dismantled, and all the other factors. And also we monitor our CO2 emissions, both in-house as well as upstream from our suppliers, and also the downstream CO2 emissions. So we have designed these products keeping in mind the sustainability goals of our customers as well as of nations and governments. We offer financing, very creative financing suitable to the requirements of our customers. We are also localization and supply chain sovereignty is a big topic. We are also localizing across many countries, not just in developed countries, but also in emerging countries to meet national requirements. And that's primarily our focus. I mean, as a technology company, that's all that we could do to fast track electric adoption for commercial vehicles. Plus, we are also beginning to play the role of a steward for net zero to proactively communicate the benefits of such net zero drivetrains so that there is greater adoption from operators and other stakeholders in the system.
I think the commercial vehicles in the end are all about consumers, individuals, citizens, and commuters. So I think the changes that you're bringing about for all of us will really make our lives better. And as you said, with a focus on net zero objectives, climate change, of course, is very important for the entire logistics sector. So thank you so much, Zubin, for joining us for this conversation. I'm sure that the work that you're doing is already visible to many of us and will be impacting urban dwellers and citizens in the years to come. Thank you again for joining us.
Thank you, Pranjal. Thank you for having me. Pleasure speaking with you.
And thank you to everybody who listened in and tuned in. I was in conversation with Zubin Sarkar, Head of Strategy, Business Development at Siemens Commercial Vehicles. We will see you again for the next podcast on Disruption Dialogues.
Thank you for listening to #Disruption Dialogues. If you are a strategy or market intelligence professional, we invite you to join our community on LinkedIn, #Disruption Dialogues.